Waking the Sleeping Giant. When the roar of German guns in Poland in September 1939 heralded the start of the Second World War, the United States, geographically shielded by two oceans, was still in the grip of deep isolationism. Public opinion, traumatized by the First World War and focused on the internal problems of the Great Depression, was categorically against being drawn into another European squabble. This position was reinforced by a series of neutrality acts. Their army was a reflection of this policy. It was not just small, it was a skeletal cadre force equipped by 1918 standards. Ranking a humiliating 17th in the world by size, somewhere between Portugal and Bulgaria, the U.S. Army still relied heavily on horse cavalry. The military budget was minuscule. As of early 1940, the U.S. had fewer than 400 tanks in its entire arsenal, the majority of which were obsolete machine gun-only models. The American military leadership watched events in Europe with growing alarm, but the real, chilling shock came in the spring of 1940. The lightning-fast fall of France, Belgium, and the Netherlands, along with the rout of the British Expeditionary Force, which was pushed back to Dunkirk, was not a feat of manpower alone, but of a new, revolutionary tactic. The German Panzerwaffe, armored spearheads acting in close concert with dive bombers, Ju-87 Stuka, and motorized infantry, proved that warfare had changed forever. The Blitzkrieg concept, championed by Guderian and Manstein, had transformed the tank from an infantry support weapon into an independent, decisive force capable of operating to strategic depths. In that moment, American generals looked with horror at their own arsenals. The truth was brutal. The main problem for the ground forces was not just an insufficient number of modern tanks, it was that they had virtually none. What was on the books was either a museum piece or an utterly inadequate machine. Toy tanks of the interwar period. Doctrinal deadlock and paralysis. The roots of this catastrophic lack of readiness lay in the 1920s and were less about technology than about doctrine and inter-service rivalry. After the First World War, fierce debates raged within the U.S. Army, as in many others, about the role of the tank. Innovators like the young Major George S. Patton or Colonel Adna Chaffee Jr. saw the future in armor, predicting mechanized warfare. But they were in the minority. The conservative majority in the Army's leadership, veterans of positional warfare in France, saw the tank merely as an auxiliary tool, a mobile machine gun nest. The situation was exacerbated by the National Defense Act of 1920. This law strictly demarcated the functions of the armed branches. Tanks were officially assigned to the infantry. According to infantry doctrine, they were to act as slow, heavily armored platforms, crawling alongside advancing soldiers at 3 to 5 miles per hour to suppress enemy strongpoints. Any idea of tanks conducting independent deep penetration operations was quashed. At the same time, the cavalry, desperately clinging to its existence in the age of the motor, saw mechanization as its only chance. By that same law, they were forbidden from having tanks. The cavalrymen, fearing complete disbandment, showed bureaucratic cunning and began developing combat cars. Formally, these were not tanks, but vehicles for reconnaissance and rapid raids in the spirit of old cavalry tactics. In reality, they were light tanks. This doctrinal split led to the creation of two parallel, but equally dead-end and poorly funded, lines of vehicle development in the 1930s. The infantry and cavalry could not share experience. They had different budgets and different requirements. This completely paralyzed the creation of a unified armored doctrine. The situation was further aggravated by the famous designer J. Walter Christie. His revolutionary high-speed tanks, with their unique suspension, which would become the basis for the Soviet BT and T-34 tanks, were rejected by the U.S. Army as too fast and impractical. The Cavalier light tank. M1 combat car. The firstborn of this new tank development was the cavalry's M1 combat car, adopted in 1937. It was a relic at birth. Its construction was archaic. The hull was assembled with rivets. This was technologically simpler than welding, which required more skilled labor, but mortally dangerous. When hit by a shell, even without penetration, the rivets would shear off and fly around the inside of the hull at high velocity, becoming secondary projectiles that maimed the crew. The armor was symbolic, ranging from 6 mm to 16 mm, capable of being penetrated by any anti-tank rifle of the era, let alone the German 20 mm cannons on the Pezek KPFW. 2. But the main problem was its armament. The rotating turret held 2 machine guns, a .50 caliber, 12.7 mm, M2 Browning, and a .30 caliber, 7.62 mm, M1919. Another .30 caliber was intended for anti-aircraft use. Despite this, the M1 was not considered a scout vehicle, but a line combat tank for the cavalry. A total of 148 of these machines were built, but their fate was grim. They never served a single day in a frontline combat unit. They were immediately relegated to training centers, where they were used to train drivers and test new technical solutions, such as the suspension. It was on them that the future standard VVSS suspension was perfected. 2. The infantryman light tank. M2. The infantry, in turn, received its own light support tank, the M2. Production began in 1935, and it became a prime example of the tactical fallacies of the 1930s. M2A1, 1935, 10 or 19 units built. Had a single turret with 3 machine guns. M2A2, 1936 to 1937, 238 units. Fell victim to the fashionable 1930s twin-turret layout, like the Soviet T-26 or Polish 7TP. The vehicle, nicknamed Mae West by soldiers after the buxom actress, had 2 small turrets arranged diagonally. A gunner sat in each with a machine gun. This was thought to be an advantage, but in practice, it was a nightmare. It complicated fire control for the commander, created dead zones, added weight, weakened the hull's armor plate, and made mounting a cannon impossible. M2A3, 1938, 73 units. Had the same twin-turret layout, but with an improved vertical volet spring suspension, VVSS, which would become the standard for American tanks for years. By 1940, as German PZK PFW, 3 and 4 tanks with their cannons and rational layouts were conquering Europe, the U.S. arsenal contained 320 to 330 M2A1 to A3 tanks. All of them were machine gun only. The American High Command, in a panic, declared this entire fleet completely combat ineffective. Only in 1940, under direct pressure from events in Europe, did the M2A4 modification appear. This was a fundamental step forward. Engineers removed the 2 turrets and installed a single cast turret with a 37 mm M5 gun, thickened the armor to 25 mm, and added 3 machine guns. This 37 mm gun was the standard anti-tank weapon of the Army, but by 1940 it was already weak. This tank was the direct ancestor of the famous Stuart. A total of 375 of these machines were produced, the last in April 1941. But they too went mostly to training. Only 50 of them saw combat at Guadalcanal in 1942 to 1943 with the Marine Corps. There, they performed adequately against Japanese infantry, and their light Hago tanks, but were useless against any serious artillery. 3. The stillborn giant, medium tank. M2. If the light tank situation was bad, the medium tank situation was a catastrophe. After long experiments, the medium tank M2 was adopted in 1939. This machine was the quintessence of the outdated land battleship concept and the fear of massed infantry attacks from World War I. The tank was tall and clumsy. The main reason for this was the choice of power plant, an aviation-style radial 9-cylinder Wright R975 engine. This engine was powerful and reliable but very bulky, requiring a tall hull, which made the tank a perfect target. The first 15 to 18 machines, M2, had 25 millimeters of armor and a turret with a 37 millimeter gun. But the distinguishing feature of this monster was the presence of 6, and, in some configurations, up to 8, 7.62 millimeter machine guns intended to provide all-around fire. They were in sponsons, in the hull, in the turret, and 2 even fired backwards along the sides. This required a huge crew, 6 to 7 men, and made fire coordination impossible. The next modification, the M2A1, 94 units built up to 1941, received sloped armor up to 32 millimeters and a more powerful engine, 400 horsepower versus 350. But this could not save the obvious junk. By the summer of 1940, watching newsreels of German pieds-à-fils in France, the Americans realized their M2 was hopelessly obsolete. Not one of the 112 M2/M2A1 medium tanks ever built ever saw combat. They merely joined the already substantial fleet of training machines. At rock bottom, the strategic choice of 1940. The final tally was depressing. By the summer of 1940, as France fell and Britain prepared to repel an invasion, the U.S. did not have a single modern tank fit for war in Europe. Its entire tank park, built over 15 years, was only good for training new recruits. The first and most important step was an organizational revolution. On July 10, 1940, bowing to the inevitable, the Army took a decisive step. It created the armored force as a separate, independent branch, taking tanks away from the infantry and cavalry. The man placed in charge was that same mechanization pioneer, now General Adna R. Chaffee, Jr. At last, tanks had a single owner who could forge a unified doctrine. But the question of equipment remained. The leadership, particularly the head of Army Ground Forces, General Leslie J. McNair, was faced with a choice that would define the entire war. Path 1. The German path. Quality. They could, like the Germans, start developing from a blank slate, creating advanced, complex, technologically superior machines like the future Tigers and Panthers. The downside, this would take a colossal amount of time, 3 to 5 years, for R&D, testing, fixing, teething troubles, and retooling industry. The U.S. had neither the experience nor the time. Path 2. The American path. Quantity and pragmatism. They could take the existing, albeit flawed, designs, the M2A4 light tank base and the M2 medium tank chassis, force their modernization, and launch them into mass production. The downside, the new tanks would be inherently inferior to the enemy's best. The Americans, true to their pragmatism, chose the second path. They decided to beat the enemy not with the quality of each individual machine, but with sheer volume. The strategy was to flood the battlefield with reliable, easy-to-produce, and easy-to-repair machines. The good enough doctrine was adopted. Mobilizing the auto industry. Birth of the arsenal of democracy. The key figure in this effort was not a soldier, but a civilian. William S. Knudsen, a Danish immigrant who had a meteoric career to become the president of General Motors. President Roosevelt, who had declared the U.S. the arsenal of democracy, brought him into the National Defense Advisory Commission, later the War Production Board. Knudsen agreed to work for $1 a year and brought the brilliant philosophy of the automotive assembly line to military procurement. He was not a tank engineer. He was a production manager. It was Knudsen who proposed the revolutionary idea. The Army should not build tanks itself. The tank arsenals should work in close partnership with the automotive giants, GM, Chrysler, Ford. He declared, "We can't wait. We must use what we have." He introduced auto industry methods to tank building, assembly line production, breaking the complex process into thousands of small, simple operations. Standardization, using identical parts and assemblies as much as possible. Network of subcontractors. Thousands of civilian factories across the country were given orders for individual components, road wheels, bolts, engines, radios, which were then shipped to the main assembly arsenals. In 1940, a plan was approved to produce 2,000 medium tanks in 18 months, a figure that seemed fantastical at the time. To achieve this, the gigantic Detroit tank arsenal was built from scratch in an empty field, with the help of the Chrysler Corporation. This was not a factory in the old sense. It was a true automotive assembly line adapted for 50-ton machines. In parallel, companies like the American Locomotive Company, a steam engine builder, Baldwin Locomotive Works, and the Pullman Standard Car Company, a rail car builder, converted their facilities. The nation was turning its factories for peaceful goods into military arsenals. Good enough. Tanks. Evolution, not revolution. American tank development followed a path of rapid but sequential evolution. 1. Light Tank M3/M5. General Stuart. The first new American tank was the Light Tank M3 General Stuart, adopted in July 1940 and put into serial production in March 1941. In essence, it was a refined M2A4. Engineers took the same layout, the same 7-cylinder Continental W670 gasoline engine, or a 9-cylinder Guyberson T1020 diesel for the Navy and Lend-Lease, and the same 37mm gun. But everything else was improved. Armor. Frontal armor was increased from 25mm to 38 to 51mm. Running gear. The VVSS suspension was strengthened. The idler wheel, sloth, was lowered to the ground, which increased the track's surface contact, improved cross-country performance, and reduced ground pressure. Technology. Instead of complex riveted hulls, they began using welded hulls and cast turrets. This increased both the speed of production and resistance to shells. The M3 tank was produced until August 1942, with 5,811 units built. Its modifications, M3A1, M3A3, and its further development, the M5 Stuart, were produced until 1943. The M5 model is a brilliant example of flexibility. When the Continental aircraft engines became scarce, they were needed for planes, engineers didn't stop the assembly line. They took 2 standard Cadillac V8 car engines and 2 Hydra-Matic automatic transmissions and combined them into a single power pack. The tank became quieter, more reliable, and easier to drive. These tanks fought on all fronts, from North Africa to the jungles of New Guinea. They were quickly outclassed by German armor, but were dependable, fast, and, most importantly, there were many of them. 2. The Savior Freak, Medium Tank, M3, Grant, Lee. The ramp-up of medium tank production began in 1941 with the M3 Grant, British name, or Lee, American name. This machine is the perfect symbol of the American interim solution strategy. The problem: the Army urgently needed a 75mm gun capable of fighting German tanks. The M2 medium only had a 37mm. The solution: the Americans had no available turret capable of holding a 75mm gun. Designing one would take months. The compromise: engineers took the chassis from the stillborn M2 medium, modified it slightly, and installed the 75mm gun in a Sponson A side-mounted casemate with a limited traverse. On top, they placed a turret from the old project with a 37mm gun. The result was a tall, over 3 meters, clumsy, 2-story tank. It was a nightmare for its 7-man crew and an ideal target. It had an archaic riveted construction, but it had a 75mm gun that could fire not only armor-piercing but also effective high-explosive HE shells. This was vitally important for the British, whose tanks with 2-pounder guns could only fire solid-shot bolts and were useless against infantry and anti-tank guns. The Grant was a known interim solution, existing only while engineers designed a proper turret. But it was these freaks, sent to the British via Lend-Lease, they received them first, that saved them in North Africa in 1942 during the Battle of Gazala, and played a key role in the Battle of El Alamein. 3. The workhorse, medium tank. M4 Sherman. Finally, the M4 Sherman arrived on the scene. This was the tank the M3 was waiting for. In essence, the Sherman was the M3 Grant chassis, on which they finally mounted a proper cast turret with a 75mm gun. The Sherman's design, adopted in September 1941, was a triumph of production philosophy. It was inferior to the Panther and Tiger, which would appear later, but in 1942 it was superior to the main German PZ-3 and PZ-4 tanks. Its design was perfectly adapted for mass production, unification. The Sherman used the same VVSS suspension as the M3 Grant and M2 Medium. The new HVSS, horizontal volute spring suspension, only appeared in mid-1944. Production flexibility. The Americans brilliantly solved the problem of differing production capabilities. Need a cast hull? That's the M4A1. For factories that couldn't cast large parts but could weld, that's the M4, welded. This flexibility allowed dozens of different firms to be brought into the production effort. Engines, the key point. The top priority for engines was aviation. The standard radial right Continental R975 engine, used on the M3 and M4, was in short supply. The Germans would have stopped production. The Americans, without blinking, began to install anything that worked. M4/M4A1, the aviation right R975, gasoline, M4A2, 2 GM671 diesels, diesel, primarily for Lend-Lease to the USSR and Britain. M4A3, the new Ford GAA V8, gasoline, considered the best, and became the U.S. Army standard by the war's end. M4A4, the apotheosis of the strategy, the Chrysler of 57 multibank. Chrysler's engineers took 5 6-cylinder car engines, joined them together in a star configuration, and made them run a single crankshaft. It was a maintenance nightmare, but it worked, and, most importantly, it kept the assembly line from stopping. M4A6, a Caterpillar diesel engine. Over the course of the war, nearly 50,000 Shermans of all modifications were produced. This is more than all tanks produced by Germany during the entire war. Conclusion: the victory of industrial logic. The Americans did not try to create a technical masterpiece. Their goal was to produce as many tanks as possible. They waged war not with quality, but with overwhelming quantity, backed by rapid logistics and phenomenal repairability. A Sherman's engine could be swapped in the field in a few hours, whereas replacing a Panther's transmission required factory-level conditions.